Hello everyone, today we'll be beginning our fourth and final section of Unit 8, covering perimeter and area ratios. So before we begin, I added the area lines here, and we aren't going to use those, so you can just go ahead and scribble those out. We're going to start with calculating the perimeter of our two figures. So perimeter is found by adding all side lengths together, so I have 10, 5, and 12, and then 20, 10, and 24. So for my first figure, I have 10 plus 12 plus 5, which is equal to 27. And then I have, for the second figure, 20 plus 24 plus 10, which is equal to 54. We're going to come back to that. All right, so before we go any further or use the perimeter, we need to think about the similarity ratio again. So the similarity ratio between these two figures, which I'm telling you that they are similar, so because they're similar, then I can take any side length, and I'm going to pick an easy one, so I have 10 to 20, and that would be my similarity ratio. So I have 10 to 20. Or we can simplify that so it's really a 1 to 2 ratio. So now we want to find the ratio of their perimeters, and we're going to see what happens between our similarity ratio and the ratio of the perimeters. So my perimeter was 27 and 54. So I have 27 over 54, if I'm writing this as a fraction, which simplifies down to 1/2, which means that I had a similarity ratio between side lengths of 1 to 2, and the ratio of the perimeters is the same at 1 to 2. So because of that, we can now use this formula where it says if two triangles are similar and the ratio of their side lengths is A to B, then the ratio of their perimeters will also be A to B. So that's with perimeter. Area takes that and it goes a little further. So we still have that same fraction of A to B, but when we are looking at the ratio of their areas, then we have A over B all squared. That's the ratio of their areas, or the formula for it. All right, let's take a look at an example. Example 1. One equilateral triangle has sides 3 feet long. Another equilateral triangle has sides 7 feet long. 1. Explain how you know the two triangles are similar. Well, they have to be similar because equilateral triangles mean that they have exactly 60 degrees for all angles, and it means that they also have the same side length measure for all sides of the triangle, which means that our first triangle is going to have 3 sides that are 3 feet long, and the second triangle is going to have 3 sides that are 7 feet long. That satisfies both side, 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 and angle, angle. So we will say that equilateral means all sides are congruent to each other. All sides and angles are congruent within the triangle. Which means that the ratio between all side lengths will always be the same because the side lengths will have the same measure no matter which sides you're pointing at. That's what that means. And we can add that too. So this means the similarity ratio between two equilateral triangles will always be the same. Will always be the same because the side lengths are all the same. All right, so in this case, if we have a 3-foot long side to a 7-foot long side, then the ratio of their perimeters is going to be the same as the ratio from one side to the other side, which will simply be 3 to 7. That will be the ratio. To find the ratio of the area, we have to take that and we have to square it. So I have 3 over 7, and we're squaring that, which means the ratio of their areas will be 3 squared, which is 9, over 7 squared, which is 49. And that is their ratio. And that actually cannot be simplified, so it's just 9 over 49. If it could be simplified, we'd want to break it down. All right, and if you aren't recognizing that this means that we're squaring both the top and the bottom, a way you could think of that is instead of having 3 squared over 7 squared, you could think of that as 3 over 7 times 3 over 7. So you're squaring the whole fraction. All right, now let's take a look at example 2. So it says assuming the two triangles below are similar, find the perimeter and area of triangle JKL. So I have 20 to 25 for my side lengths, and I don't know anything about perimeter or area over here. I'm going to start by finding the perimeter ratio because I know that that will be equivalent or proportional, not an equivalent, it will be proportional to the area for the perimeters. So for my perimeter area, or for my perimeter ratio, I have 20 to 25. And that actually will simplify nicely, which will make the math easier for us if we break that down. So 20 to 25 is, if we divide both of those things by 5, that gives me 4 fifths. So it's a 4 to 5 ratio. And we might as well go ahead and just use that for area because we know we're going to need that. So for area, that means that we have 4 fifths squared, which is equal to 16 over 25. And both of those things are going to stay right where they're at because they don't have any common factors. All right, so now I'm going to take those pieces and I'm going to set up a proportion and solve with a cross product between perimeter and area. So starting with perimeter, I have my perimeter ratio of 4 to 5, and my similarity ratio of 4 to 5, and my perimeter ratio will be 50 to my unknown perimeter, which I shall call x. I'm going to solve by multiplying across. 4 times x is 4x. 50 times 5 is 250. We're going to divide both sides by 4, which means that x is about equal to, which means x is equal to 62.5. All right, so that is the perimeter of the larger figure. So I'm going to label that as perimeter, or P new. That's what this little marking means. It's the second one, P new, is equal to 62.5. That's my perimeter. Now I'm going to find the area using my area ratio. My area ratio was 16 to 25, and for my area ratio is 16 to 25, and I know my area is 80 for the small shape, and we don't know what it is for the big shape, and I'm just going to use A for this. So I'm going to once again multiply using these cross products. So I have 80 times 25, which is equal to 2,000, because 8 times 25 is 200, and then you add a 0. And then I have 16 times A, which is just 16A for now. I'm going to divide out 16 from both sides, which means my new area, or my area from my new second shape, is going to be equal to 125. All right, so there's my perimeter and area for triangle JKL, and it does look like the K got cut off a little bit here. That's supposed to be K, and if we want to be consistent, then we would say that P is equal to 62.5, and my new area is also 125. All right, that is where we're going to stop. This is the end of our triangle similarity unit. Following this, we'll be working on Unit 9, which is an introduction to trigonometry.